which is really how many degrees? 120. Look, it's 60, 120, 180. 60, 120, 180. Okay, wow. That's supposed to be directly across. It's a bad picture. What are the coordinates of this point? Well, it should be the same as this one, right? Same y values. X value is going to be negative. Negative 1/2 root 3 over 2. How about this point right here? Negative root 3 over 2. 1/2. Okay? And then this one right here? Negative 1, 0. So what was sine of 2 pi over 3? 2 pi over 3, going up here and looking at which of those? The y coordinate. Because it's sine, right? So the answer to this would have been root 3 over 2. Now, I could keep going, couldn't I? How do I get the remaining points? Take this one and reflect it down. Take this one, reflect it down. Take this one, reflect it down. Do y'all see how I'm doing that? So what happens here? If I go from this point reflected down, this point should match up with this point with one exception. Did my x's change? Is my x value changing? No, the x's are the same, right? So this should still be negative root 3 over 2. What changed is instead of going up 1/2, I go down 1/2. So negative 1/2. I forgot this. No, that one was here. My drawing sucks. Okay. So here to here should be the same as this point. X coordinates should be the same. The y coordinates should be opposite. So negative root 2 over 2, negative root 2 over 2. And then this one down here should be the same as this one, except a negative y. So negative 1/2, negative root 3 over 2. And then we have our angles. How about the point on the bottom? 0, negative 1. And then we wrap around and we can cut this up into 3 more pieces. And those, you can bring these across, or you could bring these down. It's up to you. Doesn't matter how you do it. You're going to get the same result either way. So let's just plug these in real quick. This one should be root 3 over 2, negative 1/2. This one should be root 2 over 2, negative root 2 over 2. And this one should be 1/2, negative root 3 over 2. So do you kind of understand what I mean when I say that if you understand the first quadrant, that you can really construct the entire unit circle from just the first quadrant? And in terms of the angles, I would go back to your counting thing. You know, go like pi over 6, that's 2 pi over 6. This is 3 pi over 6, 4 pi over 6. This right here is 5 pi over 6. This is 6 pi over 6. Oh, sorry, pi over 2. This is 6 pi over 6. This is 7 pi over 6. This one is 8 pi over 6, which reduces. 9 pi over 6, which reduces. Where am I? 10 pi over 6, which is really 5 pi over 3. 11 pi over 6. And that brought me all the way back around to 12 pi over 6, which is 2 pi. And then I could do the same thing for the blue ones. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. I think everyone does better with the degrees than they do the radians, but At some point, I'm going to hand you a blank unit circle and ask you to fill it out. Not yet, but it will happen. All right? I'll give you time. Your test is on Thursday, right? So it won't be on the test. All right? On the test, I'll actually provide you a unit circle. All right?
And you'll just ask, much like the example question.
I'll ask the questions that I asked earlier, yes. But at some point, I do want you to demonstrate that you could, if given the opportunity, construct this circle without any reference. Yes?
And how would they introduce you using the unit circle approach?
Pardon me?
How would they introduce wanting you to use the unit circle approach?
How would they introduce?
Like in a question, would they just say use the unit circle approach?
No. This approach, what it's going to come down to what it's going to come down to now is that, like, from here on out, when you're in calculus or like in this class, if I say, like, hey, what's sine of negative 45 degrees? Okay? You're always going to be thinking about the unit circle. So you're sine of negative 45. Sine, y coordinate, at negative 45 degrees. Negative 45 is this way, right? So negative 45, I'm down here. Y coordinate down there is negative. I'm at the 45, so it's a root 2 over 2, so it's negative root 2 over 2, right? So that's where it comes in. It's always going to be what we use to spit off answers for trig functions fast. In my Cal 1 this semester, one of the problems we had was we were just trying to figure out what cosine of 0 was. So it was like day 2 or day 1 of the class, and I was like, okay, so here we got to, what's cosine of 0? And it was like, I heard the bag shuffling, and I was like, I wanted to throw something. Stop, put that away. If you get to Cal 1 and your instructor asks you what cosine of 0 is and you go to your calculator, that means you didn't learn it the right way. Okay? Cosine of 0 is the x-coordinate on the unit circle at 0 degrees. The answer is 1. Okay? That should not be something you need your calculator for. So does that answer your question? It is the way we get the answers to the common angles quickly. All right? It's funny, though, because I expect that to happen in a calculus class. I'll be like, what's sine of pi over 2? And it'll be like 0, 1, 0, 1. That's what students will, 0, 1. It's like they kind of remember, but not really. What is that? Sine of pi over 2? 1. See, y'all did it. 0, 1. What is sine of pi over 2? Pi over 2. Sine is the y, so 1. Okay. Take some time, go Google blank unit circle and print out a blank unit circle and see if you can fill it out, because that's what I'm going to ask you to do at some point. I think, in Canvas, I believe I put a blank unit circle in your files. There's one that's blank and there's one that's completed. So, yeah, I've already done that for you. So I would print that out and try and see if you can fill it out. I always start with the angles. I always start by spelling out all the angles first, and then I go around and fill in all the numbers. But you do what you want. All right. Okay, the following properties. Let's see if these make sense to you. The even and odd properties of trig functions. I believe I just completed the homework for this 7.5 on video yesterday. So you should be able to do the homework for this, and the video should be there.
Is the exam going to go up to 7.5?
If I gave you a unit circle, would you want to see the problems I just asked you?
Yeah.
Probably, right? Yeah. So I think I will
Okay.
because I think you want them
Okay.
as opposed to, you know what I'm saying?
Yeah, yeah.
These are almost kind of gimme problems if you have the unit circle, but you have to know what you're looking for. But if you know that, you're in business, right? Okay. I think something that might be difficult might be, where it's something like, 13 pi over 6. Like what's sine of 13 pi over 6? So then you got to figure out where you are, right? So you're really at pi over 6. So you'd have to maybe count your way around. You figure out you're really at pi over 6. Sine is the y coordinate, and the y coordinate at pi over 6 is 1/2. So that might be messy, or if you say something like, negative 7 pi, sine of negative 7 pi. So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. So I'm right there, right? Sine is the y coordinate there? 0. Cosine of this would be what?
Negative one.
-1. So, think you can handle that? The homework does, that happens in the homework. So I think if you did your homework, you probably knocked that homework out pretty quick. Does anyone have any strong objections to having that on the test? I think it's good for your grade. It should help your grade a little bit there. Everything else before this? Yeah. No, we won't have this. I won't do this. But I still want to talk about it today. This will be the last thing I talk about today. Then we can start talking test. Do these properties ring a bell? Like, do you remember hearing about these in college algebra? No? No? Let me write down what they are first, algebraically, and then you can get sick when you see them, and then we'll talk about more visually. Okay, so even functions. A function f is even if f of x equals f of negative x. Odd functions. A function f is odd if f of negative x equals negative f of x. Okay, now I'm going to give you an example of an even function and an odd function from college algebra. And then we'll come back and talk about the even and odd functions in terms of the trig functions. All right, so I'll get back to this. So as an even example of an even function is something like f of x equals x to the fourth minus 3x squared. That is an even function. Now the reason it's even is because we will get the same result whether or not we plug in a positive number or a negative number. We will get the same answer. Let me illustrate. What would f of 2 be here? So 2 in here would be 16 minus 3 times 2 right here would be 4, right? And what's that equal to? 16 minus 12? 4? Okay, we get 4. Yes? If we plug in negative 2, what happens? We're going to get the same result. Because when we take negative 2 and raise it to the fourth power, and negative 2 squared, because it's an even power, the negative really doesn't matter, does it? And because that's an even power, this is going to result in 4. So f of 2 equals f of negative 2. And this would work for any number. F of 3 would be equal to f of negative 3. F of 4 would be equal to f of negative 4. F of x would be equal to f of negative x. That's what that means. Okay? When you if you were to graph this function, if you were to graph that, it would be, I don't know exactly what this looks like, I'm sorry. I do know some of its general behavior. I know where, shit. Yeah, okay, it's going to look like this. Those are exactly the same. Even functions are reflections over the y-axis. All even functions are reflections over the y-axis. Okay? Does this ring a bell yet? No?
Yeah.
Yes? Okay, now it does. All right, odd functions. Well, I could just do that same example, except I'll do x cubed minus 3x. So notice that what I've done is these were even powers of x, and now those powers of x are both odd. Do you see that? X cubed, and then x to the first power, 1 is odd. So what happens here? If I try and plug in f of 2, what do I get? Well, 2 cubed is 8, minus 3 times 2, so I get what? 2. Okay. Now let's try and plug in f of 2, negative 2. Do you think we're going to get the same answer? Let's see. If we plug in negative 2, we do negative 2 cubed minus 3 times negative 2. So let's be careful with our signs here. What's negative 2 cubed? Negative 8. And then what's this? Plus 6? So we don't get 2, we actually get negative 2. Right? They don't match. Here, even functions, you plug in a positive or a negative, you get the same answer. Odd functions, you plug in 2, you get an answer, right? You plug in negative 2, you get the opposite of that answer. So if I plug in, let's do it this way. If I plug in 2, right? I don't get the same thing that I get when I plug in negative 2. I get the opposite of it. The negative makes it the opposite. So that's what odd means. Okay, that's just a refresher on what even and odd means. Now let's talk in terms of trig functions. Let's talk about sine theta first. Even or odd? Or neither? It is possible to have a function that, if someone just says, hey, you know, let me reach in my bag of functions and like hands you a function, it doesn't have to be odd or even. It's not one or the other. There is a third possibility that it's neither. I can give you an example of one that's neither and just make that a 4. So I've got a 4 here and a power 4 here and power 1 there. This would be neither even nor odd. So there is a third category. So is the sine function, or is sine even or odd? Well, let's try and think about this visually. And let's go back to the unit circle. Let me draw an angle in here. That's theta. Okay? I'm going to plug theta in, right? I'm going to get an answer. Where's negative theta? Down, right? This would be negative theta. Am I going to get the same answer when I plug in theta and negative theta into the sine function? Does it produce the same answer? Okay, let's try theta. Sine of theta is what? In terms of this is a unit circle, okay? Sine of theta is what in terms of that point? It's the y coordinate, isn't it? So this right here, the distance from here to here, that right there, that is sine of theta. Now, what is sine of negative theta? It's this distance, right? That's sine of negative theta. Are those going to give me the same things? Is the y coordinate up there the same as the y coordinate down here? No. But they are opposite, right? Kind of like we were getting the 2 and the negative 2. That same thing is going to happen here. You give me an angle theta, I'm going to get a y value. If you give me negative theta, I'm going to get the same y value but opposite sign. So the sine function must be odd. That make sense? How does it work for cosine? How about cosine? Theta. Even or odd? Or neither? So go back to the same picture. If you give me an angle theta, then you give me a different angle, negative theta, or not different angle, same angle but negative. Cosine is which coordinate? The x-coordinate. So if you look at this point right here, this distance right here, that's cosine of theta, isn't it? And cosine of negative theta is the exact same thing, isn't it? This is the same as this. So plugging in theta and negative theta result in the same answer. And that's what even functions do. So this is even. What about tangent? Even or odd? This one's interesting. I'll try this one with a picture. I've never done this one with a picture. If this is theta, and this is negative theta, our question is tangent going to give us the same answer on both of these, or are they going to be the same but opposite in sign? So let's see. By definition, tangent of theta is the y-coordinate here divided by the x, right? The y-coordinate in this case is this, and the x-coordinate is this. That's going to give me some answer. Down here, tangent, I'm going to have what? The y-coordinate is now negative instead of positive, and the x-coordinate is the same as the one up here. So how are these going to be related to one another? Will they give you the exact same answer? No, they're going to be actually off by what? By a sign, right? They'll be off by a sign, which means it's what type of function? Odd. Now here's some good news. All the reciprocals of these follow the same thing. So what about cosecant? Theta. It's odd. How about secant theta? It's even. And then cotangent theta is odd. Okay? So once you know the first the first three, you have all six. All right.
Does it depend on what we use as theta?
Nope. For any theta, as long as the theta is in the domain, because as we'll see, there are some values of theta you cannot plug into cosecant. So you can say that these functions are odd or even on their implied domains. And we will talk domains once we get into 7.6. 7.6 is the graphs of sine and cosine. So the graphs have domains and ranges and all that stuff. All right, let's talk exam. Is there anything, because I know you all studied over the weekend, went back through your homework, and really started to get prepared for this thing. Was there anything that you wanted me to demonstrate or that you'd like to see maybe a couple of examples of, or anything that I can do to make you feel better?
Was that an example like the one you gave us for the quiz from last class?
Oh, the one like
The one we just like turned in.
triangle one?
Yeah.
You would like to see something like that again? Okay. Do you want me to just work this one out?
Yeah, sure.
You want me to just work the quiz out?
Let's figure out the answer.
See if you got the right answer? I need to see if I can read one of these problems. Oh, here we go. This is a good one. Okay, I gave you that this was 400 feet and that you had a building over here that had a height of h. And I gave you that this, I gave you two angles here, 20 degrees. And I gave you another one here that was 30, oh, just 30, no, yeah, the whole thing, 34 degrees. I think that's all I gave you, right?
Yeah.
All right. There's so many different ways to do this. The way that I see it is that I would want to work ultimately with that triangle right there. And I would try and figure out what this is right here. So I'm going to just call this y, okay? And if I know what y is, and I know this whole thing is 400, then I can just take 400 and subtract y to get h. That's the way that I would approach it. Now, unfortunately, on this red triangle, I only know its angle is 20. So I need either to find the hypotenuse of this triangle or to find this leg right here. And I think this leg might be easier for me to find because this leg from here to here is the same as this distance from here to here. So I can call this x right here. And if I look at this triangle, that's x down there. And I know this side is 400. And I know this angle. This angle is 56 degrees. Okay, now I would just get my calculator out and I would set up a trig function here. I have 56 degrees, I have the side opposite of it, and I have the adjacent side to that angle, right? So I know that tangent of 56, I'm using tangent because tangent is opposite over adjacent, so x over 400. Do you all understand that? Tangent of this angle is x over 400. And then I can multiply both sides by 400. Tangent of 56 equals x. I turn my calculator on and I make sure that I am in degree mode. Okay, which I am. Then I do 400 tangent of 56 degrees and I get 593.02 equals x. Okay, now I can come back up to this triangle and replace that with 593.02. And now working with the red triangle, I have 20 degrees opposite and adjacent. So I can now write down a different equation. Tangent of what? 20 degrees equals what? Y over 593.02. Multiply both sides by 593.02. Tangent 20. Make sure I'm in degrees, which I already know I am. So that times tangent of 20. I get 215.84 approximately is y. So I know this distance right here is 215.84. So the height of the building will just be that, take that away from 400. So 184.16-ish. 184.16 feet. That's how I would have done it. That's not the only way, but That's probably a pretty short, clean way. It only required 2 trig functions. You could have also tried to get, I don't know. You could have then got this hypotenuse, and then you would have had the hypotenuse and this side, and that could have given you, no, 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 that wouldn't have helped. Well, there's lots of dead ends too, but, okay, what else?
What about like angular speed and linear speed?
Okay. You see something like that? A DVD spins at 1200 RPM. The DVD is, or has, I should say, has a 5-inch diameter. Part A, find linear speed of a point on edge of disk. Part B, find angular speed of disk. You got a DVD. Again, it's impressive, I understand. So this thing is spinning, right? Spinning around. It's going around 1,200 times per minute. So you need to understand that RPM stands for revolutions per minute. So it's going around 1,200 times every minute. So which of these two would you like to go after first? I don't care. Angular is actually the easier of the two computations. Because the angular speed is just the total angle you turn through divided by the time it takes you to turn through that angle. Now technically it's what? Omega is theta over time, but you know, again, do you really want to bog yourself down with memorizing things? Just think about it. It's total angle over time. Isn't speed distance over time? So angular speed is distance of the angle, which is the angle, right, over time. So do we know the angle that we go through here? Okay, it's, oh wait a minute, hold on, yeah, 1,200, I kind of already gave it to us, right? So I know I'm going 1,200 revolutions, I'm going to put revs, per 1 minute, right? The only thing you have to do is convert that into either degrees per minute or radians per minute. And it's your choice. I think you should go with radians because linear speed uses radians, so radians is probably a good thing. So each revolution is how many radians? 2 pi. So all you have to do is take 1,200 times 2 pi, and that's per 1 minute. Oops, minute. Minute. All right, which is 2,400 pi radians. You don't have to write radians, but it's nice to be clear per minute. And that's all I want. I don't even need you to like multiply by the decimal and get me an answer. 2,400 pi radians per minute is your angular speed. All right, part A, find the linear speed. So how do we find the linear speed of a point? Multiply the what?
The radius with that, right?
The radius times this? Okay, so if you like formulas, what was the formula for linear speed? S over t, which is radius times theta over time. S was arc length. Now, we already know what this is. Omega over time, right? Omega. Theta over time was omega. And we already know that that's 2,400 radians per minute. So if we just take that, I think this is what was being suggested, is take this and multiply just by the radius, we'll have what? What is the radius? 2.5 inches times 2,400 pi radians. I'm gonna go back to this notation, radians per minute, like a fraction. So 2.5, because I gave you the diameter, the radius is half of that. So now we can go approximately, let's go ahead and just do this on the calculator. I'm gonna actually approximate pi. So I'm gonna take 2.5 times 2,400 times pi. I get 18,849.55 something. So I'm gonna say about 18,850 what? Inches per minute. Is that fast? What if I asked you to give me the linear speed in miles per hour? Can you do the conversion? 18,850 inches per 1 minute. Let's see if you can do the conversion. Let's first take care of minutes. We want minutes to be hours, right? Now, I didn't ask for that here. This would have been the end of the road had I not specified I wanted it in miles per hour. But if I said in miles per hour, you would then have to do this. So minutes, how many minutes are there in an hour? 60. So I just go 60 minutes in 1 hour here, right? Okay, the minutes would cancel. Then I'm going to multiply. Now I need to get inches to miles. Well, I know that there are 12 inches in a foot. And I know that there are how many feet in 1 mile? 5,280 in 1 mile. You might want to remember that. It comes up a lot. I mean, it does. Feet to miles. And everyone understand why I positioned those conversion factors where I did so that units would cancel? Yep, here, 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 here. All right, so what I should do now is multiply across the top 18,850 times 60. And then take that answer and divide it by these two multiplied together. So make sure you do this correctly on your calculator if you're trying to do it all at one time, putting your parentheses in the right place. 17.85. Approximately 17.85 miles per hour. That's the speed of that point moving around. So as it spins, if you were to imagine that being a straight line motion, it'd be traveling at almost 18 miles per hour. I'm out of time. I know y'all are nervous about the first test. I think that's natural, especially because I'm not like giving you a review. But like I said, do your homework, make sure you've gone through that. And go back, look through your lecture notes, the types of problems I gave in class. and we'll see how it goes.
Do we expect one like the first one that you did with the triangles? Like, do we expect one that big?
That,
Or similar? Then the one before
well, I think you should expect it. I think you should expect it. Yeah, I mean, just because. Why not? I mean, I don't want to tell you don't expect that. Right? The test will be the entire class. Yep.
There was, I think there was a picture that you wanted us to handle last week. I don't know which one.
Oh, the one that I didn't take the grade for?
Yeah, I think I took it off.
Yeah, it's okay. You can bring it next time.
Okay.
Yep. Yeah, y'all are supposed to bring your binders next time too. Oh, let me turn off my camera. Let me get by you here real quick to shut this thing off.